Hello everyone, good morning. Hope you all would be safe and sound at the home and welcome to the Null Ahmedabad meet of uh, on the November month. So let me just give you a short introduction about Null community. Null is India's largest open security community registered as a non-profit society. We uh, we have been active for more than it's been 10 years now, and the main motto of Null is to spread information security awareness, and we organize monthly meets. We also have workshops which are divided into three categories. The first is Null Hamla, the second is Null Bachao, and third is Null Pulia. So in Null Hamla, we spread the knowledge of the offensive security background. In Null Bachao, we spread the knowledge about defensive knowledge, and in Null Puya, we spread the content of both offensive and how we can defend it. So there are multiple projects done by Null, and the most and the one of it is Null Job Portal. So as you all can see here on the website, so we have 16 chapters active running in the whole country. And this are the map shows the chapters located. As you can see, Null has also a mailing list where you can join, which to be updated about the activities done by Null. If you are interested to become Null volunteer of any of the local chapter, you can register here. And if you are interested to start a chapter at your local state or any surrounding, so you can start a chapter and register here. So this is the homepage of the Null website. The if you want to visit the chapters nearby, you can visit on the chapter portal, and here you need to sign in first. So to get register, so here is the Null Ahmedabad chapter, and if you want to know who are the chapter leaders, the leaders are Bashit Pandya, Jaimin Goel, Namrata Brahmshaktiya, and Ravi Rajput. So this is a short introduction about Null. Um, so let us start with our today's meet. The first talk is by Arman Pathan, and he would be delivering attacking post message. So let me add Arman to the stream. Yes, Arman, so you can unmute yourself and start.
Yeah, hey everyone. Let me share my screen.
Yes.
Uh, so guys, can you see my screen?
Yeah. Okay. Yes. Now it's visible.
Okay, cool. So yeah, I'll be talking about post-message exploitation. So hello.
Yes. The voice is
Yeah,
audible.
okay. I thought I got some issues. Okay, yeah. So I'll be talking about post-message exploitation. So previously, I guess in September, I have delivered the same talk in Dubai. So maybe you will find the same content in this one. But yeah. So I'll start with myself. My name is Arman, and I work with Emirates as a application security engineer, where we hack planes. And yeah, I'm quite active bounty hunter on Sinak, Hackern, Background, and Cobalt. And yeah, that's me in the photograph. So yeah, what's post message? So before taking a deep dive to the post message, why post message has introduced. So have you ever seen, like, if you notice that there is a button login with Facebook or something like that. So whenever you click on login with Facebook, it pops up a window. So when it pops up a window, origin gets changed. And if origin gets changed, then if the second window has to share any of the data with the first window, then both origin has to be same, and the application has to define the origins. And in if an application will not be able to define origin, then in that case same origin policy, which is known as SOP, will get triggered for the browser security purpose, and it will not allow an application to make a cross communication between two different windows. So to bypass that, the same origin policy, the post message function got introduced. And if you go to the Mozilla documentation, you will find more details about the post message function, that what it is. But according to the Mozilla documentation, window.post message function safely enables the cross origin communication between two different windows or two different objects. For an example, I have said that when you click on the login with the Facebook, it pops up a different window. So it's like same like example, cross origin communication between the page and the pop-up that is spawned by clicking any of the buttons or making some actions on the main window. So yeah, that's it. So yeah, that's the problem while making a cross on origin communication. So when you click on some button on the main window, it pops up a different window. And from the different window, the main window tries to fetch some data or maybe request for a data. In that case, the both the windows will not be able to make a communication because of the same origin policy. So yeah, solution is the post message. So we can in such scenarios we can use the post message function to bypass the same origin policy. So this is how we can define application message function. Basically there are mainly two methods, like so in the main window you have to add the event listener, which is known as called as add event listener, in which you have to define a origin, that from which origin or from which domain an application should receive a data. um, and on the second window which is popped up, which is known as a target window, which will be sharing the data to the main page. So in that page, obviously message will be there, and you also have to define the target origin, that with which website you are sharing the data. So so yeah, this is how you can implement the post message function into your application. mm, Finding post messages in an application. So basically what people do, people just dig the JS files of an application, and they'll find lots of post message functions in it. But it's very difficult for anyone to find post message reading all the JS manually, when it comes to pen test, or when it specifically comes to bug bounties. Because in bug bounties, there are like big applications such as Uber, Airbnb, Facebook, and they have lots of JS files. So it's very difficult for any researcher to find and read all the JS files. So to make it easy, Franz Rosen has made one Chrome plugin. So whenever you will enable this plugin, it will automatically reads all the JS files and list out all the post message functions which are used by on that particular tab. And this makes, as you can see in the screenshot, this makes quite easy for pen tester or researchers to find out all the post message functions, and he or she can easily read out the functions and can find, if there are issues, they will be able to find it. Yeah. So so let's come to the point, like misconfigurations that most commonly developer makes while using the post message function. So yeah, uh, using wildcard at the target origin in target window.post message. So uh, uh, as you can see in the screenshot, as I have previously explained, that when on the secondary window which will be sharing the data, the developer has to define the target origin, that with whom this particular window is sharing the data, sharing the information. So because of the lack of the knowledge and to make things easier, what developers normally does, they gives a wildcard, or you can say star, into the target origin. So in that case, application obviously will be sharing the data with the main, sorry, the window will be sharing the data with the application or the main window. But since it's a wildcard origin, which means it will be sharing the data with every listener. So in that case, let's say, if I'm having I have enabled the event listener on the another tab, and there is no relation between the main application and the popped up window. Still the popped up window will be sharing the data to the another tab or another window. So yeah, this is the main so basic uh example. So let's say there is one page which has a button to fetch the values. So whenever user will click on the fetch value buttons, an application will make a call on /value /1, in which the window will get popped up. And this path dot value dot one contains this JS, which has window dot opener dot post message, and it has a value or message as like test value. And as you can see, it is using a wildcard origin. And the main page which has that button, it also has this the function add event listener, which will be actively listening all the values which he which window one will be sharing to the main application. So in that case, obviously, the popped up window will share the value, and as you can see in the script, it is getting passed in the get element by ID. And this is how post message works. But since as you can see on the window.opener.post message, it's using the wildcard origin. That means an application is sharing the message or you can say value with every event listener. So how we can exploit this? So what in that case, what an attacker can do, uh, an attacker can craft a malicious page in such a way that it contains event listener, which will be continuously listening to the data. So in that case, whenever, let's say, if I'm sending I have crafted such a page which contains the event listener, and I am sending that page to the victim. Now in a background, my page is actively listening to the all the events. So whenever victim will click on the button which is popping up the window will get popped up. And since and in that particular function, the target origin is star, which means it's sharing the data to everyone. In that case, it will share the data with my malicious crafted page. And as I have defined my domain over here, it will leak all the data on my domain. So yeah, this is how it will look. So I'll share just crafted HTML page on to the victim, and as soon as victim will open, and or maybe after, just by just opening, or maybe uh, after opening the malicious page, if victim makes any clicks on the page, the data will get shared, and it will leak the message on my on my server, where I am hosting that crafted page. So this is the way how we can exploit, if you know uh, if target origin is wildcard, in which the popped up window is sharing the data with everyone. So this is the way how we can exploit. So any questions till now? uh, hello.
Hello. Yeah, we don't have any questions yet.
Okay, fine.
If
I hope there are no
Yeah, there are
questions.
no questions in the chat.
Okay, cool. Mm, yeah. So how to fix this misconfiguration? So as I have said, to fix this misconfiguration, you have to define a proper origin, in which you have to define a proper protocol, a domain name, and the port number, to prevent this kind of attacks. So once you will define the protocols, domain name, it could be a subdomain, and the port number, port number will be can be anything. So once you will define this, it will only share the data to the defined origin. In that case, if anyone will try to steal the data or the information or the value by using this method, then the SOP will get triggered, and in that case, the popped up window will not be able to share the data with malicious page which contains the add event listener function in it. Yeah. So as I have said earlier, to use the post message function, the main page has you have to also define the add event listener function to the main page, which will be continuously listening, the listening that if any popped up window or any other tab is sharing any data to the main page or main application. So to define add event listener, you have to define the origin as well, so that from which origin the application should receive the data. Once you will so but most commonly, because of the lack of the knowledge, developers forgot to define the uh, main origin, or you can say the origin to the add event listener function. In the particular case, you know uh, you can craft a malicious page in such a way where you can define the target origin with as a main applications or domain. And once you will open that malicious page, the message will get shared with the main application, since the main application has not defined any origins. So all the messages from the malicious page will get shared to the main application, or an application which is using a add event listener function, but it has not defined any target, any origin in it. So yeah, since as you can see, the the code, it has not defined any origin, and it's passing the value which is getting from the popped up window to the inner HTML. in that case, if malicious page shares any kind of malicious payload, such as XSS payload or something like that, it will directly gets passed into inner HTML, and it will get executed within the DOM. So yeah, in that case, you will be able to perform cross-site scripting attack, or maybe DOM-based cross-site scripting attack by abusing it. So let's see how an attacker can abuse add events listener function to get the XSS. Uh, yeah. So as you can see, the main window contains the add event listener function, and the event data, which is fetching the values from the popped up window, and which is passing the value into the inner HTML. So let's assume the main application contains there is a one application which has the button, or the main application that only has this the button, or maybe some value, and it contains this add event function in it. And on the field, it's fetching the data from by using the post messages. So what an attacker can do, as you can see the second window, an attacker can craft an HTML form in such a way that in that he can define the target origin, and he can define the access payload as a message. So since uh, I have just defined star as the origin, which means it's sharing the message with every event listener. You can use star, or you can you define proper origin. If you know the domain name or something like that, then you can define the origin that it should only get shared. But it won't make any changes if even if you will define the star as a origin in your target origin post message script. So yeah, so what this script will do, it will directly open this URL into a frame, uh, just to get the session. And once it will get the session, it will share the post. It will So since this domain contains this post message function add event listener, the listener will start reading the messages, and after that it will this malicious page will directly shares the messages to the event listener, in which it will pass the access payload, and the access payload will get passed to the inner HTML. Since it's not escaping any HTML entities, and it's directly getting passed within the DOM, and it's not validating the origin. The access will get triggered within the DOM, and this is how it will look. So once victim will click on the malicious page, it will load the malicious script which contains the post message function, and it will execute the XSS. Cool. So how we can fix this issue? So to the main page which contains the add events listener function, there we can define a check where it will check the origin. If event.origin not matches with the origin which is defined, the request always the SOP will get triggered, and it will drop the request from the target origin which is sharing the message. So yeah, in this case, in add event function, add event listener function, you can add a condition that in which you can define the origin with proper protocol, the domain name, and the port number, that from this protocol, from this domain, and from this uh, port number, the value should get passed. if any of the values are different, then the SOP will get should get triggered, and it should drop the message. So yeah, this is how you can fix the add events listener function misconfiguration. And also you can add such checks that uh, whenever even if you it's validating the origin, it should check the message, and if the message contains any sort of HTML entities which can execute the XSS, it should escape all the HTML entities before passing to the main DOM or the main values. So in that case, you won't be able to pop, even if the origin is getting properly validated, you will not be able to perform XSS or something like that. So I'm just taking a test case. So I guess everyone has gone through this blog. So one of my friend Vinod Kumar, who works with Zomato, found very cool access to actually he found two DOM based access in Facebook. So yeah, he was just learning about the post messages, and he was just going through the post messages functions in the Facebook, and he found he found a just a moment, uh yeah, yeah. So he found a vulnerable post message function in which an add event function was not validating the origin value, and also the value was directly get instead of escaping the HTML entities, the message was directly getting passed into the DOM, and it was not validating the message. So Facebook has a login SDK, right? I mean, all you know that as login SDK gives you feature to integrate in your application, in which you can click on, just you will just click on the login with Facebook, and uh, login will make Facebook will generate an token, and that particular access token will get shared to the main application, and the application will use that particular access token as a as your credentials. So whenever you click on the login with Facebook, the Facebook JavaScript sends the initial payload to the iframe proxy, and then iframe proxy will open this particular URL, www.facebook.com/version so and so/dialog and over.php. And while opening this window, uh, it loads at one post message function, which is add event listener function, which is continuously listening the message which is getting shared with the to the Facebook from the Facebook itself. So the post message function looks like this. As you can see that window dot open, in which it just opens the window. I.url is a message which the Facebook is receiving as add event listener function is receiving as a message, and ID is just a normal ID, just to define the user ID. Since, as you can see, there is no the Facebook has not defined any validations regarding the origin value, that there are no checks. We can exploit this by using the target post message function. So in target post message function, we'll be sharing uh, the message with every, every origin. The message, as you can see, that origin is, I have used the origin as a start. And in the var message, in the message variable, you can, as you can see that, Vinod has used javascript.alert document domain as the url's value. So whenever, Vinod or an attacker will share this, that this particular HTML, malicious crafted HTML page to the victim, this particular target post message function will get loaded. And window.open will just, open the facebook.com, just to fetch the session of the user, or just to, load the Facebook. And this post message function will get, after then, this post message function will get called. And in the add event listener function, the malicious page will, share the ID, which can be anything, and the URL, which is javascript.alert. Since, there are no origin check, and also not checking for any HTML entity escaping or something like that, javascript.alert will directly get passed into window.open. And in that case, window.open will directly execute that particular javascript.alert. And in that case, you will be able to perform that access into the Facebook. So yeah, that's the demo video. Let me play. So yeah, that he has shared the uh, malicious HTML page, which contains the malicious post message target origin post message function. So whenever victim will open, and he has, make it more fancy, like click here for the access. So whenever victim will click here to execute to perform any actions, the access will get executed. And it will directly fetch and users cookies or victims cookies. Yeah. So as I have said, first he has loaded uh, the Facebook. And then in the URL, he has used the malicious HTML code, which will execute the accesses. Yes. So yes, as you can see, it has shared. Yeah. So as you can see in the screen, FB DTSG. So basically, FB DTSG is nothing but the CSRF token, like they call as FB DTSG, the Facebook IDs and the Facebook cookies. So yeah, this is how you can abuse when the target origin is not defined. Sorry, the origin is not defined in the add event listener function, and it's not validating the message. This is how you can, abuse it, and can execute access with it. So yeah, that's it. Any questions, guys?
Um, no, there are no questions till now. If anyone would be having, they would be commenting in the YouTube chat, so you can answer them there at that time.
Can you just share the YouTube link again? Yeah, you I'm just
I think you are not audible. Can you repeat it, please?
I just said that can you please share the link to the chat box?
Um, Thank you, Arman bhai. It was really informative session. So let us move with our second speaker. He is Satyam. So let me, Satyam, are you there? Yeah.
Yeah, am I audible?
Welcome, Satyam.
Yeah, thank you.
Satyam, you are not audible.
Hello. Hello.
Yeah, we can hear you.
Am I audible now?
Yes, yes.
Okay, great. Just a second. Uh, can you see my screen?
Yeah, it's visible.
Okay, great. So, hello everyone, and this is I'm Satyam Gothi, and we'll be seeing about how to get started with API hacking. And so, let's get started. So first of all, let me tell you something about me. I am an associate security consultant at Securelayer 7. It's a company based in Pune in India. I'm also a part-time bug bounty hunter, and I have found like several bugs in Sony, Edmodo, Dell, Red Bull, and some other companies. I also play some CTFs. I haven't been playing a lot recently, but I used to play some CTFs as well. I also have a small little YouTube channel and a blog as well. So yeah, and after all, I'm just another newbie in the infosec scene. So that was just something about me. Let's just get started. So this is just today's agenda. Like we'll be seeing what are APIs and why are APIs so famous, or why are you seeing a lot of APIs being used everywhere today? What are the security issues which you can find with APIs, and where exactly to look for to find those bugs, and what could be those issues. And we'll be seeing some bugs and POCs as well, which I personally have found during my pen testing assignment, or some bug bounties as well. So yeah. Now, what exactly is an API? So API is not API is just application programming interface. The technical definition for it is like it is a set of routines, protocols, and tools for building software applications. But that doesn't make quite some sense. So it just think of it as a waiter. Like for example, let me just show you. So think of it as like this is you, this is your computer, a PC, or whatever. This is the client, and this is the API. Think of it as a waiter. So you just request it, like I want this thing. It just sends your request, forwards it to the server, and I'm very bad at drawing, so please pardon me about that. Now, the whatever request you send to the server, it processes the request here, and it sends the response back to the client, which is you. And this communication takes place with the help of this REST API or APIs in general. There can be basically two types of APIs, which are REST and POST, which are REST and SOAP. Sorry, but SOAP APIs are a very less common these days, and REST is the new thing which is generally being used. So we'll be talking entirely about REST APIs itself. So whenever you encounter a term or whenever I say APIs, please just consider it as REST APIs itself. And REST API uses HTTPS, and the messaging format which it uses is through JSON. So this was just what exactly is an API. Now, why are APIs being used everywhere? So, like, there were applications in the past, and there were a lot of great things going on in the past as well before the era of APIs itself. So why do we even need APIs, and why are they being used a lot these days? There are basically three main reasons for the use of APIs: security, speed, and scalability. Like, first, the application, initially before APIs, the application used to be monolithic, which means there was this huge chunk of application which was developed as a whole. But APIs, what APIs does is it helps to divide each application into smaller chunks. So you can think of it like, for example, this is the whole application, and maybe let's say this is a sign up function. This allows you to post some messages. This allows you to comment on something or any post. This functions allows you to upload some photos or images. So what APIs helps us do is it helps to individually develop each of these particular functions. So the function which is responsible for you to help you comment on the pictures of post of others is completely independent from the login function. And the upload feature or upload function is again completely independent from all other functions. So what this helps to do is it helps to break down the whole application into different smaller chunks. And due to this, it helps to increase the security of the overall application. Like, you just need to focus the developers just need to focus on one particular function to completely build and secure, and then move on to the second, and so on and so forth. And also it helps in like scalability, because there are very less dependencies. These two things are completely independent from the first one, and vice versa. So there are no dependencies in the application. So if tomorrow the developer decides to add a new function, let's say some maybe integration with a third party app, they could just easily code that part and add it to the integrated to the application, because there are no dependencies for it with all other chunks of the application. So that is one thing. And also, if it also helps in falling back as well. So what I mean by that is, let's say there is a problem in the sign up function. So maybe the sign up or sign in function breaks for some reason or so. Now what happened before that, because there were very a lot of dependencies in the application, if one of those functions would break, all other functions would be affected because of that single piece of error in the code. But as all these are independent now, if one function breaks, all other functions or all other parts of the application remains intact, and they are not affected by the any of the breakage in the code of any single particular function. So that is why APIs are being used a lot these days, because it helps in, as we discussed, scalability, speed, reliability as well. And yeah, another part is security. Let's say if you would have seen some sign in with Google or sign in with Apple features or functions on any of the third party application, which are maybe not part of Google or not a subsidiary of Google itself. But before that, if you wanted to, before the era of APIs, if you want to like share a single particular function with a third party, it would be like very troublesome, because you would have to give access to the third party to your entire database or code. But due to the introduction of APIs, you just need to give access to some of your particular APIs to the third party, and they can just interact with those APIs, and only that part of data will be shared to them. There is no need of sharing the entire code or giving access to your entire database to any third party. So that vastly increases the security and intercommunication between a lot of different types of softwares or web applications. So yeah, that's it. And yeah, where are APIs? So every time, so like currently, every each and everything is based on APIs itself. So every time you visit a page online, you're sort of interacting with an API. Maybe if it's a shopping app, or it's a gaming thing, or maybe you visit some social media, APIs are everywhere. So this was just something about APIs again. Now, what can be the security issues with these APIs? So OWASP again has released its top 10 security issues considering APIs, and of that we'll just look at some of the most critical and trivial ones, which are very like kind of not that hard to find, but provides a very great impact if exploited in the wild. So these are some of the common and critical vulnerabilities which are usually found in APIs. The first one is broken object level authorization. So it's just another word for IDOR. IDOR, as you might be knowing, is a kind of vulnerability in you know web applications, where you just need to change the ID of one user to maybe from one to two, and you'll be fetched with the data of that user. We'll see it in detail further. Second one is broken user authentication. It basically defines the authentication issues, like you might be able to log in without an actual ID password or without any authentication at all. Next is excessive data exposure. So this is information disclosure, and this information disclosure is kind of very common and very basic thing which a lot of people are finding these days. And there are a lot of information disclosure issues, like if you are active on Twitter infosec or are a little bit into bug bounties and stuff, you might be seeing a lot of people reporting information disclosures and things like that. So that is that is very common these days. And what it is like, for example, it's nothing nothing that rocket science. It just is, if you, for example, let's say, are asking for a pizza, but in return you are getting a pizza, a burger, and a dessert as well. So you can think of it that way. So that is just information disclosure. Now, the next one is lack of resources and rate limiting. So, as you know, this is the common rate limiting vulnerability. So, sometimes what might happen is there are usually, and of course, there are not unlimited resources on the server, even if it's Google or whatever XYZ company it is. There are some limitations to the number of resources the server has and what amount of information it can process at a per single particular time. So if there is no rate limiting on any particular endpoint, the user or an attacker might just keep on repeating the same request, and it will exhaust all the resources in the server, which might result in a denial of service attack. And brute force, as we all know, it's just nothing. If there is no rate limiting on, maybe let's say a login function, which is implemented with the help of APIs, then you might be able to, the attacker might be able to brute force the ID or password with the help of exploiting this vulnerability. The next one is broken function level authorization. Now, these are the access control issues. If you try to compare it with web application security or web application things, and this is nothing but the issue role based issues. So for example, if there are two different roles in an application, one is admin and one is normal user. If there are any issues in the authorization, if there are any issues in the authorization, the normal user could try to access the features or functions of the admin user as well. That is broken level authorization. Another one is mass assignment. So it is like initialize or override server side variables, and we'll just see this in more detail next. And the injection vulnerabilities, as we all know, cross-site scripting, SQL injection, template injections, etc., can also be exploited or targeted using APIs as well. So these were just a basic overview of these vulnerabilities, and let's just see each one in detail and maybe some POCs as well. So what and where to look for? So we'll just see. Now, as we discussed, broken object level authorization. So BOLA, this is BOLA, and this is just another name for IDOR, as I said. So what basically happens here, or how can you actually find or exploit this vulnerability in APIs? Whenever you maybe traverse an application, or you have bob suit running in your background, and just you are just intercepting all the requests traversing through the web application, and you encounter some request when visiting your profile or something. So if that request is like slash API slash personal details and 1001, and here 1001 is just nothing but your profile ID or the ID associated with your particular account. And if you try to access API personal details 1002, which is not your ID, and if it returns back all the details of another user, well, yeah, that's a vulnerability, right? So these it's very it's very easy, like you just need to change from 1 to 2 or one ID to another ID. This is just a simple example. See, these IDs might not be sequential, because nowadays applications are getting more secure. So even if they are not using sequential IDs, you can just try to associate all the IDs, or maybe their IDs are something which are not sensitive, right? So for example, if your ID is, let's say, let me open Paint. If your ID is, let's say, 10842, this is your ID, and uh, this might be your profile ID. And if you try to visit any if considering it's an like application like Facebook or something, and if you visit some other person's profile, and there usually the ID might be exposed in the page source, or in the URL, or somewhere like that, some place like that, because the ID itself is not sensitive in nature. You cannot do anything with this ID itself, right? So these IDs are generally exposed, or are usually public, you can say. So if you visit the profile, this is, let's say, me, and if you visit the profile of any user, let's say B, and you fetch the ID, and you see that the ID is 17296, then maybe you could try to insert this ID instead of this 1002 here. And if the data is being fetched back, there you have it, a very easy to exploit, but the impact is huge, as you can see, because it might return all your personal details, and any personal details if are exposed, most of the use organizations consider that as a critical vulnerability. So yeah, and these were for GET request, because just these requests just fetch the data back, nothing else. Now for it, this can be the same in the post request, post requests as well. Post request in the sense, like if you are updating your information, or if you are adding new information to the server, even in those requests there can be IDOR as well, or BOLA, you can say. So if there is any API, which, let's say, API update info -1, and in the body there are maybe email, password, name, etc., which can be updated. And if there are no checks for authorization. If you change the id and try to update the username, email to anything else, and if it can be updated, again a critical level vulnerability. So this was something about bola. And this is just an example of this particular vulnerability which I had found during a pen testing engagement. So what it was is, here as you can see, this is a particular id, and this is nothing but just the api key find here. And this particular id gave results of, let's say, my things or my profile or whatever this data was returning was related to me itself. But changing this id to something else, maybe 97, returned all the details of other user as well. So this were like a practical example of this kind of vulnerability found in the wild. And there are a lot of issues concerning this broken object level authorization in apis nowadays. So you can just try to change that id to 122, or change that id to some other users, and you never know what's the harm in that. So, and this was just a report on HackerOne, and it was on NordVPN. The bounty was $1,000. And all he had done is, this was a post request, and it returned the data of all the orders. And in the body of the request, there were details like all kinds of details: action, order, plan id, and there was a parameter named user id as well. So what the attacker did is, he just changed the user id to some other user id, and it returned back the all the order details of that particular user. So all he had done is changed a single field, a single id, and that was like that brought him $1,000. So you can see how critical this vulnerability can be. Now the next thing is a broken user authentication. Now AP this, as we discussed, like if there are no authentication checks, or like for example, if there is a login based entry, maybe the id and passwords are not checked, maybe the password is not checked, or maybe some token based authentication is taking place, and the tokens are being not checked, that creates a broken user authentication issue. So what happens? API is considered to be API is considered to be internal, and thus does not require any authentication. So what happens in organization these days? There are some APIs which they do not expose publicly, and they are considered to be internal because the organization do not expect those APIs to be found in the wild, right? So they are considered internal. But if so, there are no authentication or any level of checks on accessing those APIs, like whether the user who is accessing these APIs is authenticated or not, or is a part of organization or not, because these APIs are already considered internal, and they expect that these APIs will not be found by any of the users. But if somehow these APIs are being found by a particular user through maybe brute forcing or some other methods, then yeah, you can you can imagine what will be the consequences, because internal APIs are are very critical APIs, you can say, because they might be returning a lot of personal information or sensitive information, you can say, with the in the perspective of the organization. So if those APIs are found and exploited, that is a very critical issue again. And as I discussed, static or weak authentication tokens might be another issue. So, for example, if the target is using, or if the organization is using JWTs, and if there is any issue in the JWTs, this will be a whole topic in itself. So, just imagine that the JWT authentication or the JWT configuration has some issues, and the signing of the JWTs is not being checked. So any user can just create their own token and access all the APIs which are present in the application. So that is an issue. A token generated using default or weak ID or password, which can be easily guessed or found. So, for example, what happens is, let me see. So let's say there is a login endpoint, and it has a user and a password. So whenever you enter this user and password, in the response they give you a token back. A token is given back in the response, and this token is further being used in all other endpoints, like maybe slash v1 orders or whatever it is. All these endpoints take this token as an authentication, but consider that this id and password are maybe very weak, which can be easily brute forced, or which are some default, maybe let's say admin. Then this token will be easily generated by any of the user, as these are, just the default passwords, and then you can easily access all the API endpoints. So this is another thing which can happen. And and there are a lot of times where, authentication tokens are exposed in maybe URLs or the page sources or JavaScript files of the web application itself. So all you just have to do is look at the page source, check the URLs and JavaScript files, and if there are any tokens hard coded into the application, you just you do not need to do anything. You just directly found a critical vulnerability, and you can directly exploit it using those token itself. Or sometimes what even happens is tokens are simply not validated. So what happens, there might be different tokens being generated for different users, different types of, you will see the difference between a token of user 1 and user 2. But what happens is there might be only checks based on the length of the token or something like that on the back end. So for example, if there is just a 10 digit, for example, if the token for user 1 is like, these are 10 characters, right? And the token for maybe user 2 is something like, so what happens is these two tokens might seem different at the first glance, but what is happening on the back end is it's just checking if there are 10 characters in the token. So and if there are 10 characters, it does not check anything else and it just validates it, right? So what an attacker can try, or what you can try as an attacker, is like provide any token, any random token which has 10 characters in it. And if the checks are only based on the length of the token, it will validate this token, and the API endpoint can be accessed and the response will be fetched back to you. So these might so all some of these things might seem very very stupid and trivial, which of course should not be happening, but trust me, I've personally seen these things happen a lot. And if you just traverse through activity on HackerOne, there are a lot of issues which will make you laugh. That, like, issues like these are even existing right now, but yeah, they are, and they actually pay a lot of, bounty or a lot of things for such easy critical vulnerabilities. So these were some examples of broken user authentication. And this is just another example. Just a second. So this was again on a pen testing engagement. Now what happened, that there was an admin endpoint, and it just revealed the information without any access token. As you see, we have an access token header here, but we have not provided that header in the request. So even without providing any authentication header or any kind of authentication in the request itself, the data is still being fetched back without any authentication. So this is another example of where this issue can be found. And here another thing which again was found in a pen testing engagement. uh, there was an endpoint, there was a user management login endpoint. So as I discussed, there can be two steps where first you log in and then a token will be provided to you. So what was happening here is you just had to provide email and password and the token will be fetched to you. But due to this broken authentication, even if there was a blank password, there was no actual check on the password itself. So you just provide any email and the access token would be fetched to you, and then you can use that token to access any of the API endpoints in the application itself. And yeah, this was HackerOne report. This was on Stribo, and as we again discussed, the API keys can be easily found, or you may be hard coded in the JavaScript or page source itself. And yeah, this guy, excuse me, just found that the API key, some API keys were directly, just hard coded into the application, into the JavaScript file, into one of the JavaScript file itself. So yeah, this was a very easy finding, you can say. Now the next one is excessive data exposure. So API returns all information and the client does the filtering. And if the API is accessed directly, yeah, there's an issue. So what might be the misconfiguration here is, like, if when you request anything through an API, all the data is being fetched back. Let's again. So if you just access API slash details, it will fetch all the data, like details or maybe just name. So what it will do is, from the backend, all the details will be returned back, like email, name, age, location, etc. All the data is being fetched back as the response of the API. But what happens is, to the user, only the name is being fetched back because the user just requested for the name, right? And only the name is being shown to the user. But this the API returned all the data, but to the user only the name is shown. So the filtering, all this filtering from, like, for we got all the data, but the filtering takes place on the client side. So the website itself just checks if the so the website itself checks that, like, if only the name is being requested, then I will just uh, take this name and then display it to the user. If the age is being fetched, I will just take the age and display it to the user. But all this filtering just takes place on the client side itself. So imagine if you just directly access this API endpoint. Here it was accessed through the web application. Here it was accessed through the web application. Let's say there might be a function called, profile, and when you clicked on this profile function, it triggered this API in the backend. All this data was fetched, and the client side filtering took place, and only the name is being displayed back to you. But now imagine you just directly try to access this endpoint, not from the web application. You just directly, maybe do a call request or something like that, and try to access this API endpoint directly. So what will happen is, as it returns all of this data as the response, and as there is no client in this case, so no client side filtering will take place, and thus all of this data will be fetched back to you. And just combine it with another issue, like maybe IDOR or something, and you just have yourself all the data of any user in the organization. So yeah, this is another critical issue which is very easy, you can say, to find. And even this misconfiguration is found a lot in the wild. This was excessive data exposure, and that was one thing by which it can happen. And the second one is, like, assume the organization assumes that the endpoint in question won't be accessed without some authentication, but if the token is leaked somehow, oops. So yeah, again, as we discussed, if there is any checks being takes place, Like without any authentication token, the endpoint will not be accessed. But there might be issues with the ID password. The token might be leaked in the response in the page source or JavaScript file, or it just simply does not validate. So the attacker will get the token easily, and then if even this misconfiguration is in place, leveraging all that and chaining all those things together, you will easily find all the details of any person in the organization. So it's all about like all these issues are interconnected. All of these issues which we are discussing here are can be like chained together, and which results in the very critical end result. So that was it. And I hope I'm not going too fast or it's not getting too boring. But yeah, and also I'm not a PPT guy, so these PPTs might seem a bit too boring. So pardon me for that. Never mind. Let's just continue. And these were some examples of reports I found on HackerOne. This was on Uber, and it was paid $6,500. So what happened here is a public API endpoint leaked mobile API token of a user, bypassing the UUID in the request. Now using that token, attacker could have gained access to the driver account. So what actually is happening here is maybe there was a request, something like there was a request like this. So there was a request like this, and it returned the token to access the or access all the APIs as we discussed. It returned the token for for this particular user, and then you can access all other API endpoints using this token in further request. But what happened is the endpoint which served the token itself was not having any authorization or authentication checks. So what happened here is, if providing 1002, the attacker was able to find the token for this particular user, and now he could access all the endpoints, all the APIs, and thus all the details for this particular user as well. So as we discussed, this year it is like chaining 2 to 3 API issues together, and all the details of any user in the organization are being exposed to the attacker itself. So that was a report. It was on Uber, and they paid $6,500 to that particular guy for this vulnerability. Now another one was on mail.ru, and it again paid $8,000. So what happened here was API endpoint at some subdomain of mail.ru allowed access to subset of order and client relation information without proper authorization. Broken authentication in the client API allowed retrieving sensitive information about clients. So like what happened here is a potential attacker just needed to know client's phone number for exploitation. So what happened here is there might be an endpoint like maybe details and number. These will be just a phone number, some phone number here, and it returned all the details of that particular user, or all the details in question, maybe about the order or invoices or anything sensitive in nature was being returned just by providing the phone number of that particular user. And this phone number is something which is not that hard to find, right? You can find a phone number for that, and maybe if the application was of that nature that it allowed to view other users phone numbers and stuff like that, you can easily fetch that phone number. And there were no other checks on this particular API endpoint, like if the user is authenticated, or if the user has an actual authorization to access this endpoint and get the orders or invoices of this all the other users as well. So this was a very easy exploitation of critical level vulnerability, and mail.ru obviously paid $8,000 for it. So yeah. Now, lack of resource and rate limiting. This is pretty straightforward, and as we discussed, for example, here if there is maybe no rate limiting on maybe some upload or retrieve functionality, where you are able to like upload some documents or retrieve some data, some like a good amount of data, which is obviously resource intensive, and thus lead, and if it does not have any rate limiting, it can lead to DOS. Like if you just keep calling maybe slash API slash retrieve details, and it might be fetching the details of maybe all the users in the application, but the details are not sensitive in nature, so it might be getting us all the posts by that user, the comments by those users, and stuff like that, which are not sensitive in nature, but there is a lot of data being fetched back. And if there is no rate limiting on this particular endpoint, if the attacker keeps on calling this particular API endpoint, maybe let's say 10, 50 to 100 times in a very less amount of time, and it just keeps on calling it, the resources on the server will eventually get clogged and utilized pretty fast, and thus it will result in a denial of service. So this was just a simple example of how a normal rate limiting can be very what can we say, very effective to the organization. And as you know, like if even for if Facebook or Google or organization of that massive level even are down for some minutes, they incur huge financial losses. So depending on the impact which this particular denial of service is creating, the the whole exploitation or the issue could be considered very trivial as well. And brute force attacks, these are just normal brute force attacks, as we discussed. If there is no checks, there is no rate limiting on a login endpoint, you can just an attacker can just brute force on the username and password and try to find the credential for that particular user or for any particular email ID. So that was it. And now broken function level authorization. So as we discussed, maybe admin endpoints or APIs are just hidden, and there are no particular checks for that those APIs. So for example, what I mean by that is, let's take this as an example. If this is the API, if this is the API which has all the authorization authentication checks, and it verifies if the user is authenticated or authorized to the organization using some token. But what happens is, there is another endpoint, maybe something like this, but this does not have any checks at all, because this endpoint is not exposed or not being called in any of the requests in the whole of the web application. So it is assumed that this endpoint will not be found by any of the users. But what happens if we just directly, if we are just curious and try to maybe replace user with admin and try to mess with all these objects and variables, if we are somehow able to find this endpoint, all the data of all the data of all the users in the application, or maybe as we say any sensitive data in nature, is easily fetched back to us without any authentication at all. Maybe you do not even require to have an account in the organization itself, and all the data will still be fetched back to you. So this is something which we can call as broken function level authorization, because this endpoint is supposed to be accessible only by admins, but as a normal user or as a random unauthenticated user as well, you are able to access the function which are only supposed to be accessible by admin. And that is what we call as broken function level authorization. So yeah, as we discussed, if you can figure out or find out the hidden methods or endpoints, you are in you are in, luck, I guess. And it can be, for example, there can be maybe different ways in which you can try to find or exploit this kind of issue. And it can be as simple as just posting a get request. So for example, if this is a get request, if if this is a get request, and try to do the same request again, but now this time the verb is just post instead of get, then there are possibilities, or there might be, misconfigurations on the server side, which does not expect a post request but are getting a post request, and the server or the backend might get confused, and it just returns all the data, or maybe some data which it should not be returning itself, some more data which should not be returning. So this is another, like, very easy, trivial, and a funny thing. But yeah, this is also something which you will, if you try to find on activity, you will see a lot of such issues as well. So that was one example. And yeah, we already discussed this one, like, if there's an endpoint with API user slash me, and it returns all your personal information. If you just try to access API admin all underscore user, it returns information for all the user in the application. So that's an issue. And this is another example by which this kind of issue can be, exploited. So let's just see. Now let's say the application is quite secure, and there are, all the checks. If you try to provide admin instead of user, then you are maybe thrown unauthorized or unauthenticated error from the application. And there are no bola or any other issues in the application by which you could try to fetch the data of other users. If like try to access the features of admin as a normal user, all the particular checks are in place, and the application is quite secure. So what you can try is, like, if there is an endpoint of registering to the application, maybe let's say the endpoint might be something like slash register slash new. This is the endpoint which is responsible for registering new users to the application. And but again, there is another endpoint which is maybe API slash someone slash new. So, like, for example, consider that an application only allows invited users, or users with some kind of invitation, or maybe a request which is sent by an already present user in the application. Only then you are allowed to be a part of that organization. And this this is this request is triggered through this endpoint. So what I mean to say is, for example, user 1 is already a part of the organization, and user 1 can invite other users to the organization. No users can directly register to the organization, but only the users which are part of the organization can invite other users to the organization, right? So if user 1 is already a part of the organization, it has an access to this endpoint, which is this, and it can thus invite new users to the organization, right? So this is an example flow, you can say. But what happens is, this endpoint does not have any checks, does not have any authentication or authorization checks. Again, like, if user 1 is already part of an organization, and it just triggers this endpoint using the UI itself, using the web application itself, but there are no checks being taken place on this particular endpoint. So if you directly try to access this endpoint as an attacker, or as, as someone who is totally unauthenticated or even not a part of the organization, and just have a look at the post body, what are the data, what is the data which is being, which is being passed as the parameters, you can register yourself as an admin to the application itself, right? So here the application head checks whether the endpoints being accessed are from a normal user or an admin. So if the endpoints were being accessed by normal or like unauthenticated users, it just denied everything, right? And if it were from someone who is part of organization or like maybe you can say admin, only then it allowed access to all other endpoints of the organization or endpoints of the web application. So here this was not possible, so we just registered ourselves as an admin, and now we can access all the endpoints through this credential or whatever the flow is. This was another example by which you can abuse this particular issue, or this issue might be found. So yeah, that was these were some examples for broken function level authorization. Now the next one is mass assignment. So this is nothing but just guessing and adding parameters to request. So for example, a normal request might be maybe post API new user new register. So this is an endpoint for new users to register in the application, and as a body you just provide an email address. But for example, if you just are curious and if you try to add maybe parameters like is underscore admin is equal to true, or maybe you can try one, or maybe admin one, or things like that. I hope you get an idea. So and if there are no checks being taken place, and if this is the correct parameter, and then you will be able to register with an application within the application with admin privileges just by adding a custom parameter, because there are no checks being taken place on the backend, like if the parameter is being added by the client itself or the user itself or not. So this is what we call mass assignment, and this admin is just an example. You can try maybe different kind of objects, like if there is something in the request view which you see, maybe in the response there is let's say there is something which has allowed and it is false, you can just try to provide manually within the request as allowed true, right? So these are the things which you can try, and which can result in data being leaked or you being able to access data which you generally should not be able to. So that is one thing. And this is mass assignment, like adding parameters to request manually, and if there are no checks for those on the server side, it's an easy win. And injections, as you all know, like all the basic injection, cross-site scripting, SQL injection, template injections, etc., are can be exploited using this particular APIs as well, through APIs as well. So here what happens is, let's again see here. So let's say this is the web application. It is like behind a web application firewall. Let's say this is a WAF or a firewall, and then it's the backend server, right? So whatever you try to provide here as an input, it is filtered here through the WAF, and then it is passed on to the backend database, and after that that response is being fetched back. And now whatever you try to do here, whatever you try to provide here, everything will first go through this firewall and will get filtered here before reaching the backend itself, right? So there is no way for you to maybe uh, do any injections or things like that, because the firewall will probably, imagine the firewall is the most secure firewall in the world, right? So all the request or all the injections which you take place will maybe be encoded or sanitized or things like that, and then it will reach the backend. So nothing will happen here on the backend. It's quite safe, right? But on the other hand, let's consider the same application is having APIs as well. So usually or at times there can be flows in which what happens, the web application passes through a web application firewall, right? But the APIs might have direct access to the backend server itself. So for example, here if there is an API endpoint to maybe like create some create post, and it has some maybe name of post, and here if you try to provide uh, accesses, here if you try to provide accesses or SQL injection payloads, it will directly go to the backend server without any sanitization here in the between, because there is nothing in between the web like API request and the server. And thus it will and thus, like, a good old alert box will be popped up right there for you. Or maybe you can exploit SQL injection, template injection, any type of injections can be exploited if there is such kind of a flow. So it does so all. And as you know, like, nothing here is guaranteed, right? These are all the things which you could just try out and see if there are any kind of issues prevailing in the web application or prevailing in the APIs itself. So yeah, that is quite a possibility as we discussed. And yeah, that was it. Thank you. Thank you to Null. Thank you for everyone for joining here on Sunday morning. And yeah, if you have any questions, sure, ask me.
Thank you, Satyam. It was really great explanation. I We don't have any questions till now in the chat. So if you are having any questions, you can comment in the YouTube chat, and Satyam, you can answer there.
Sure, sure.
Okay.
Okay, not a
So,
problem. Thank you so much.
okay. Thank you. So next we have Adokjan Mishra. So he would be delivering the talk. So it's up to you. Yeah.
Okay. Hello, everyone. I hope you can hear me. Sir, can you confirm that you can hear me?
Yeah. Yes, sir.
Okay, great. So, the previous two talks were really interesting. I'm glad I got to learn a couple of things from you guys. And in comparison, my talk now looks rather lame. But anyway, let me share my screen. Wait. Mm, submit. Screen. Okay, can you see my screen now?
Yes. Yes.
Okay, great. So, today's talk is going to be about hypervisors. Mostly, I will be talking about uh, what is exactly a hypervisor, how a hypervisor works, how it is written, and where we can actually utilize this in our malicious stunts. So, that is the basic agenda of today's talk. So before I start, this is the agenda. We will start from basic introduction, then we will go into virtualization, its history, types of hypervisors, hardware systems. Then we will look into some common uses of hypervisor, and we will look into how an actual hardware boots up. Then we will compare it to a virtual machine, especially hardware assisted one, how hardware assisted virtual machine boots up. And then we will look into how to write a very small minimalistic virtual machine and run some sort of payload inside it. And then what we will do that we will try to convert all this code into assembly that can be trivially converted into a shell code if you want. So I will be showing you some C code to show you how a hypervisor is written. And once that part is done, then I will show you similar assembly code where a lot of things are commented, and I will explain how things are going on in assembly, and then you can take that and you can modify it further to make it a proper shell code if you want. So that is the basic idea of today's talk. So here goes a legal disclaimer. Basically, whatever I am going to show you is mostly for educational purpose only. You are not really supposed to use it anywhere without proper authorizations, yada yada. Basically, if you get uh, land in hot waters because of this, please don't come to me. I won't feel responsible at all. And now, here goes my introduction. Mostly, I'm a independent security researcher, not fully independent because my employment is part of this security research. I'm mostly interested in offensive side of things, mostly malware and cryptography. And in past, I have presented and attended at various security conferences, various meetups, including various Null chapters and OWASP chapter meetups. Currently, I am working in Optics, that is kind of smaller company which makes some security tooling, something like an EDR. I am working as a malware researcher, who mostly focuses on Linux specific things, basically working out how to find new attack vectors for malware, trying to figure out if something else has been utilized in mass or in some other malicious samples, and a bunch of stuff related to that. So my job is mostly part offense research, part defense research, and then we combine it into some sort of product. For contact, you can contact me on LinkedIn because this is the only social media right now where I am available, or you can drop me a mail. I am okay with both. So now we will start with virtualization and its definition. Basically, it is a process of where we run a virtual instance of some other hardware on top of some other hardware. For example, if I have a laptop with me that is running Windows and I want to play some sort of rather classic game which was not available on computer but on some sort of console, probably you have done this, but there are certain software that will let you run console games on your laptop. So, especially old classic games, you can play them that way. So, that is one example of virtualization. And this part actually started with mostly with business cases, but it really took off because of gaming and people's love for playing various games. So that is one of the many good things that this gaming thing has given to us. So now the history is actually quite old. Most of us don't really realize how old things are. For example, if you remember, VMware was not really a thing too long ago. I think it was in 2004 or 5, yeah, something like that. And even at that time, the first hypervisor I got to know about was virtual PC. I think it was from Microsoft that let you install another instance of Windows inside Windows, so you can sort of run a virtual machine. Again, here I am pulling this from my memory because last time I dealt with virtual PC was, I think it was in 2006 or so, when Windows XP was the most common operating system sold with desktop computers. So, but the history goes much before than that. So, the first trace of virtualization that we see is in 1960 when IBM developed something called CP40, which was a virtual machine time-saving operating system. Then in 1970 to 72, there were various iterations of System 370 and similar things. Then in 1999, VMware announced first virtualization product on x86 architecture. Then 2006 was when we started seeing application streaming for first time. So if you don't know what exactly is application streaming, it is like this: you start an application which is hosted on some other endpoint, just like videos. So for example, if you want to see a video on YouTube, you open the link and video is downloaded from remote server to your browser as it is being played. So you don't have to download whole video before you can play it. You can start playing as soon as some chunks of the video are downloaded. So same thing was applied to applications as well. You start with a very bare minimal set of instructions that give you some sort of UI, and as you proceed with the software, so related chunks of code gets downloaded on your system to run if you proceed further. So that was the idea of application streaming, and 2006 was when it was first seen as a product. Now, there are various types of virtualizations, and the types depend upon how we try to classify things. So, there are multiple ways to classify virtualization as well. For example, one basic way to classify them is to see whether they run directly on hardware or whether they need some other operating system to run on. So, many of you, I think, who are in this security industry or in DevOps sort of things, you probably already know that there is a product called ESXi, and some of you will probably also know that there used to be something called a Zen hypervisor from Citrix. Uh, and probably you also have used something called KVM directly for hypervisor. So apart from this KVM thing, this ESXi and Gen are called type 1 hypervisor or bare metal hypervisor, because you don't have to install any other operating system on hardware. You just take this particular product, you install directly on the hardware, and then you create virtual machines on top of it. So that is type 1 or bare metal. Second one is where you need to install some sort of operating system, and your hypervisor runs on top of that operating system. For example, VMware Workstation is there. This is type 2 hypervisor. Or if you use QEMU on Linux, that is again type 2 hypervisor. For example, if you use VirtualBox, that too is a type 2 hypervisor. So this is one way to classify virtualization. Another way is to classify them based on the technique, how they virtualize things. So the first type of virtualization that we saw was emulation. For example, if you want to play some game that was only available on some sort of console, and you want to play it on your say Windows machine, you probably need some sort of software that will emulate that particular hardware in entirely in software. So that is called emulation, because here you don't really get any benefit from underlying hardware. You basically have to simulate everything inside software. The benefit is that you can basically emulate anything on top of anything else. So to emulate a gaming console, you don't need another hardware with similar platform. You can emulate that anywhere. But there is a disadvantage, because everything is emulated in software. The emulation will be slow. So if you are going to emulate that is already very slow to begin with, that is fine. For example, if you are going to emulate pretty old DOS-based machines, that will be okay. You will still get more performance in your emulator than on actual hardware. But if you are going to emulate something that is already pretty fast, that is where the performance penalty comes in. For example, if you set up QEMU without using KVM, or you try to run ARM Linux on x86 chip using QEMU, the performance will be really slow, because ARM chips are rather fast now, and since we are emulating whole thing inside software which is running on some different type of hardware, there is going to be rather bad performance penalty. Then once we were on this, it was deemed necessary that we should provide some sort of hardware backed speed up to this virtualization thing, especially if you want to emulate same hardware that is running our own hardware. For example, if I have a Intel CPU 64-bit, and I want to run a 64-bit machine on same instruction set architecture, so the thing is that I don't really need to emulate everything in software, because whatever instructions I am going to encounter, my underlying hardware is already capable of running that. It is just that I need some sort of a way to protect that from meddling the host system. So this is where hardware assisted virtualization comes in, where you get some sort of extra features in your CPU that will let you create a virtual machine and run instructions from virtual machine directly on your physical hardware, while ensuring that anything running inside the VM cannot fiddle with anything running outside the VM unless you sort of bridge them somehow intentionally. So, for example, if you use VirtualBox that is using hardware assisted virtualization, or if you are using Camo with KVM, that is again hardware assisted virtualization, or if you are using, say, Hyper-V, that is again hardware assisted virtualization. Then finally, the third type of classification that we can do that depends upon uh, well, the extent of virtualization and how we are going to run the code. So for virtualization means that we sort of virtualize everything, whole software environment, hardware environment, everything. So what happens that we allow applications to run unmodified. That is full virtualization. And para virtualization is when the virtualized applications are run in some sort of isolated domain, something like a sandbox. So you can take sandbox as some basic example of para virtualization. But the only problem is that for para virtualization, you have to modify the programs that are going to run inside that. For full virtualization, you don't have to do anything because, well, we are going to virtualize an actual computer in full capacity anyway. Then this we are back to hardware assisted virtualization. As I already told you, we get some hardware backed features here, which lets us run instructions on directly the CPU, while ensuring that guest and host cannot fiddle with each other unless we bridge them somehow intentionally. And when it comes to history, in 2005, Intel added virtualization in its CPUs. AMD did in 2006, and VIA added in 2008. This is another vendor that makes x86 architecture-based CPUs. Apart from Intel and AMD, it is just that they are not really popular these days. But there was a time when VIA CPUs were really, really popular. Then, sometime later, things like PCI pass through and network virtualization got added. PCI pass through, probably you already know it, especially if you are using uh, VMware, where you can sort of make it like your physical graphic card becomes part of virtual machine, and once you pass through it to a VM, the VM will get full access to the GPU and your host will lose access to the CPU. So that is PCI pass through. You basically attach n number of devices on your PCI bus, and then in hypervisor layer you select which piece of hardware goes to which VM. So instead of multiple VMs sharing same hardware, every VM gets dedicated hardware to run on. This is also known as IOMMU, Input Output Memory Management Unit. And if you want to enable PCI pass-through in Linux, there are some kernel flags, especially I think Intel underscore IOMMU, that you can read about if you want to dig into this in more detail. Now, there are some limitations on this from software point of view. First one is that these instructions are limited to ring 0. That means to run those instructions, you need to be in kernel. But then you cannot really run your entire hypervisor inside some sort of kernel. That will be utter stupidity. So what we do, that we write a driver that runs in kernel mode, and that driver will run the virtualization related instructions on our behalf. So our code sits in user space. We communicate with uh, our driver using channels provided by operating system. It may be using some virtual device or some sort of named pipe sort of thing, or maybe using virtual file or virtual socket sort of thing. Depends from operating system to operating system. But the end result is that we somehow communicate with the driver. We say to our driver that, hey, do this stuff on my behalf. So driver is running inside kernel. It will run those instructions and it will get back to you that, hey, I ran these instructions and this is the overall result of what you asked me to do. And other benefit of this is that we don't have to provide one-on-one mapping between what we talk with the driver and what the driver runs on the CPU. So we basically can wrap a lot of things. So for example, if I want to create a VM, so instead of issuing multiple instructions one after another, I can set an interface to which says basically create a virtual machine, and then driver will generate corresponding instructions and run on the CPU, and then it will give me some sort of result saying that, okay, I created the VM, here it is. Or maybe I cannot create VM because this thing failed or something like that. So that is the added benefit of this driver stuff. Now there are softwares which use their own drivers. For example, VMware, it has its own driver in Windows and Linux both. There are some software which will support multiple drivers. For example, VirtualBox has its own driver, and it will also work with Microsoft specific driver that comes with Windows that is powering Hyper-V. I'm not sure whether VMware supports Hyper-V or not, so I didn't include that. But VirtualBox has support for this Hyper-V. Now there are some software which they do not have their own drivers. They fully rely on other some different driver provided by someone else. For example, QEMU. QEMU doesn't have its own kernel mode driver for hardware-assisted virtualization. On Linux, it assumes that you have KVM. If you don't have KVM, or if you disable that or block that, then QEMU won't be using any hardware-assisted virtualization system at all, because it doesn't have any driver to use. Now, some operating systems may provide standard drivers. For example, Linux has KVM, Windows has Hyper-V, and some operating systems may provide rather complicated interface for complete virtualization. For example, Hyper-V, you can run VM directly on Hyper-V without having to involve some third-party hypervisor. This is how your Windows subsystem on Linux runs, by the way. But on Linux, there is no such thing that I am aware of. You have to use some sort of hypervisor that can talk to KVM and manage your virtual machines. Now, the obvious question: why are we even bothering with this much garbage? Of course, we can install VirtualBox, or we can install VMware, and we can go our own merry way. Why are we delving into their types, their drivers, their instructions? For me, the reason is very simple. I want to use VM because I want you to not be able to debug what I am doing inside my VM. So the basic idea is this: there is some sort of some malware analyst who is going to reverse my code. So what I do, that I pack part of my payload and I create a VM. I put payload inside the VM and I run it there. So if you try to debug that I will show you in the demo. If you try to debug that, what you will see that, okay, there are some VM related instructions, something is being sent. You can capture that part. But then the thing is that what happens in Vegas stays in Vegas. So whatever is running inside the VM, you won't be able to inspect that or attach your debugger to that part of code unless my hypervisor gives you some channel to attach a debugger. For example, QEMU has inbuilt GDB server, so you can attach GDB to code running inside VM even before some operating system starts. But if I do not do that, then you are stuck. You can capture whatever is going inside VM, but then there is that. If my VM is using hardware virtualization, and again, I'm not really limited to standard programming practices. I am uh, okay, actually, I am allowed to have fancy things like self-modifying code and sort of stuff that will make your life even harder. So that is the main charm behind this, for me at least. No, I already told you that this can be used as anti-debugging, and it is not that this is only me proposing this sort of brand new idea that hey guys, look, we can do this. It is not that. It's just not that case. The thing is that it is already being used for anti-piracy sort of things. For example, maybe you are familiar with products like VM Protect or Themida. Sorry, here spelling mistake is there. It should be Themida, not Themdia. These products, they take your code, they pack it inside their own customized virtual machine that has its own uh, non-standard architecture. So you don't really get to debug that easily because instructions from your compiled code get modified to be able to run in the virtual machine which these products are going to create inside VM. So if you attach the debugger, what you will see that you will end up attaching your code to their hypervisor, which is again not very straightforward to begin with. So even if you are not going to use hardware assisted virtualization, if you are going to use emulation, even then it is really effective, especially if you have uh, non-standard architecture inside your VM. Which is this becomes really effective strategy as anti-debugging or anti-reversing, you can say. In hardware assisted, yes, we have same architecture, but then debugger will not attach to anything that is inside the VM. That is the limitation. So we are going to rely on that particular limitation. Now here we will start with now nitty gritty details, seeing how things work. So, if you want to boot the VM to start, emulation is really easy. We just start the application, we start everything as an application, so we don't have to deal with hardware specific initialization sequences and their quirks. For hardware system virtualization, well, we are sort of stuck because this will starts almost like a real computer, not exactly like a real computer, but still almost like a real computer. So we have to be a bit careful with what we are going to do here. So before I get back to the virtual machine, I am going to cover how your computer boots. And no, I am not going to talk about there is a bootloader and there is a kernel because that's come at very late stage in the picture. I am going to cover your firmware stuff and hardware initialization stuff because that is what we have to deal with. So when you press your power button, your motherboard has a firmware which used to be called a BIOS. Now it is UEFI. So what it will do that it will initialize power gates using GPIO, and then one of these gates, actually these gates are going to power on different parts of your motherboard. Your motherboard is actually some amalgamation of different chips sitting on same particular PCB. So your firmware is going to power on most of them one by one, and one of these gates is going to power on something that we call peripheral controller hub, that is informally known as chipset, especially if you are a guy who builds his own computer, and or if you go to purchase a motherboard on a shop, you will probably uh, see that there will be some line saying that using Intel chipset something something something. So that chipset is basically your peripheral controller hub that is generally provided by CPU manufacturer. So if you are going to use Intel CPU, your motherboard will have a chipset from Intel. If you are going to have AMD CPU, your motherboard is going to have a chipset from AMD, and so on. And then this peripheral control hub has its own firmware, which will then start booting, and then it will reset the chipset to a known good initial state. Then finally, it will, after doing all this, it will start power good pin to CPU and initialize and reset other pins as needed. This is where your CPU gets to start its own firmware. Again, CPU is going to have its own firmware. It is not going to rely completely on your board. Now, since CPU is on, And as soon as CPU is on, it will start executing post sequence where it will start testing bunch of hardware. At this stage, microcode updates, if there are any, they may get pushed to CPU. For example, if you have paid attention, many times you get firmware updates for your system, which are basically going to update your UEFI or BIOS, and most of the time it contains microcode updates that get pushed to CPU. And if you are using Intel, you don't really have to update your firmware either. You can push this from operating system too, but on Windows land, this is a common practice to update the firmware and push it from there. If your motherboard has TPM and trusted execution environment, they will be initialized and set up. And after post is done, there is no error. Firmware will jump to reset vector, but the problem is that we have not configured memory, and that means that we are going to deal with memory. Now, your motherboard has RAM and it is still not initialized. So, without initialization, which is again a rather complicated process, we cannot really use the RAM even though the physical sticks are present. So, what we will do that we utilize a little trick where we use the cache, the L1 cache that is sitting inside the CPU dice. We try to use that cache as RAM. The only drawback is that it is really, really fragile. If you rearrange your variables or you move them a bit up and down, it is going to break. So you have to position every single variable in this part of code really carefully, but again, we are not going to do that right now. And then what we do, we enable the cache by clearing the cache disable bit in control register 0. Again, this can be only done in ring 0, not anywhere else. And then we perform some dummy reads or maybe writes if we want, otherwise reads are sufficient many times. Uh, oh, sorry, here I have another spelling mistake. It shouldn't be this one. So what we do that, suppose our L1 cache is say 64 KB or 128 KB, or maybe we have 1 MB cache. So what we will do that we will perform a dummy read on a memory address range as large as 1 MB. So what it will do that it will try to map that address with your cache, and then we will disable the cache. This is called no fill mode because no new lines are brought in the cache because of new access and invalidation sort of things. Since nothing is brought in the cache, nothing is going to get retired, and read and write are still going to hit the cache as long as we are going to limit ourselves on those dummy addresses. So for our all practical intents and purposes, this part of address will be mapped to cache, and we are going to utilize cache as RAM. Now here, once we are done this much, then your firmware is going to identify which DIMM slots are occupied, as in where some chips are inserted. And your every RAM chip has a special chip called SPD, that is read using system management bus, which is a bit comparable to I2C protocol. And this particular chip, this SPD one, this will tell your firmware details about memory timing, memory topology, how big is the memory, and so on. Then your firmware will collect these timings, perform some testing, and then finally it will initialize your memory controller, telling it, okay, these many DIMM slots are occupied, and these are the timings. There are these many timings actually. If you are wondering, you can read about them on Google after some digging. But again, this is not completely dependent upon this SPD part, because your firmware will try to fiddle with your RAM to figure out most optimum set of conditions, basically timing, voltage, sort of thing, where your RAM is giving best performance, and then it will tell all that details to your memory controller. And then finally it will tell it that these are the sizes and this is the rank of various chips. And at this stage our RAM is pretty much initialized except routing part. So here routing part is last one. It's again depends upon whether our system is some sort of, this is something called NUMA, non-uniform memory architecture. So in this case, source address and target address decoders are set up so that the memory requests are routed via these QPI or UPI links, and then we have to boot some application processors, and then we have to configure memory controllers which are associated with those application processors. So after all this stuff, our RAM is pretty much ready, and now our CPU is ready to run some actual code. But the problem is that this is still not going to work because this CPU is not going to look anything remotely familiar to you that you have ever seen, because it is not going to execute 32-bit machine code or even 64-bit machine code, because it doesn't understand them yet, because this is in real mode because of compatibility reasons. So what happens that either bootloader or operating system, depending upon how things are set, but generally what happens that your bootloader will hand off to operating system in by setting this back to real mode. I'm not sure about UEFI because many UEFI boards are able to boot the CPU directly in 64-bit mode. So on those boards, these things will be a little bit different. This is especially applicable to a bit older boards right now. Then your operating system is going to check how many cores are there, and then it will loop over them, switch each core to protected mode, that is 32-bit, and then it will switch to long mode, that is 64-bit. And it is not like you can move only in this direction, you can go back as well. You can switch from long to protected to real, and so on. Now, when we come to virtual machine, our virtual machine is going to behave rather similar way, except there is no firmware. The firmware part we have to handle for most part, but the CPU is going to start in real mode. That means that unless we are going to switch the CPU to protected or long mode, we have to ensure that our payload remains in 16-bit real mode. And the limitation of this is that there is a upper limit on memory. I think it is 1 MB or so. Yeah, I think 1 MB is maximum limit that real mode can have. After that, you have to switch to protected mode. So this is the limitation even in virtual machine. I'm not going to cover how to switch modes on CPU because that is something out of the scope of this speech, at least right now. But if you are interested in that part, you can look into forums dealing with operating system development, or you can look into source codes of various toy operating systems that are hosted on GitHub, or even you can look into source code of Linux to see how it is done. If any of you need concrete pointers to see actual code, I will be happy to provide that. So this is the first thing, that CPU is going to start in real mode. And second, there is no standard hardware. Anything that we want to use, we have to supply. So this is one more thing that we have to take care of, and that means that all communication that we are going to have with our VM is going over generic IO ports. And since a physical CPU has IO ports, virtual CPU will also have IO ports, and we will use these IO ports to talk to between host and guest. Now, there are two ways to create a virtual machine. This is on Linux. One is to use this /dev/kvm. This is the kvm driver. We can use this directly, and then we emulate required hardware on our own, or we can use libvirt. This is basically KMU wrapped inside a library. So this gives us a virtual machine with the standard hardware pretty quickly, but then it is more suitable if you are going to use some run-of-the-mill operating system inside the VM for one-off or some non-standard stuff. This KVM stuff is the best way to go. So this is what we are going to do. Now, the first step, we have to open this particular device. Then we have to confirm the version number, because older versions are not going to work. And this version number that we are going to check here, it is stabilized since kernel version 2 point something, if I remember correctly. So if this version is not there, that means that something is wrong. Either we are on really, really old kernel where KVM is not really going to work as expected, or there is something else fiddling with our code. So yeah, it is changed to 12 in Linux 2.6, which is pretty old actually, and it got logged as stable interface in 2.6.24. So we have to check only for this particular version. This is not going to bump. Now we have to check some for some extensions, because we are going to utilize this particular extension for handling the memory. So we check for the extension as shown on this slide, and once we have the extension, we can proceed further. Now here there are certain extensions which may use their own this IOCTL calls. So there are two ways to check for them. One is to use this particular code. Here we pass the ID for desired extension, or we can trigger those IOCTL directly, and if that particular extension is not available, that IOCTL call will fail with e-notify. So there are these two ways for checking these extensions. Now we have to create a virtual machine. What we did, we opened this KVM driver, we checked the API number, we checked the extension, and now what we do here, we are creating a virtual machine, and then we will attach some memory, some CPU, and pass it some code. Now for memory, there are again two ways. One is to trap every single memory access. Anytime our code tries to read from memory or write to memory, we trap it, we halt the VM, we get notification on hypervisor layer, and hypervisor handles this and passes the data to VM, or grabs data from VM and passes it elsewhere. But this is going to be really, 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 really slow. The upside is that we have complete control over memory. Second method is that we allocate some buffer in host RAM and pass it off to VM, and VM is going to utilize this buffer as hardware RAM. This is going to give us highest performance possible, but control over memory access is largely gone, because we cannot do special funny things on memory access. Most of the time, actual hypervisors will do some part of this and some part of this. The reason is that by doing little bit of both, we get to regain control on some part of memory, while we pass some part of memory completely to VM for maximum performance. And if you are trying to emulate various hardware, memory mapped IO is going to be one way. Of course, we can do over generic IO ports as well, but this is another way. There are these two. So if we are going to deal with memory mapped IO, we can do this by trapping this memory accesses on certain address ranges. So this is the most common strategy that most of the actual hypervisors use. So what we are going to do, we are going to do this. We allocate a buffer, we pass it to VM. We don't bother with having any control over memory access, because that is not really what we are looking to right now. So what we do, we allocate one page of memory, that is 4 KB. Then we copy whatever code or data that we want to pass to VM, and then we tell the VM that, hey, this is your RAM. So this is our memory allocation using mmap. Again, here I can of course use malloc or something else, but here I am using mmap and these things, because this is going to be much simpler to translate to assembly. Then we copy the code in memory, and then this is how we populate this memory region structure, and then we tell that, okay, this is your memory region to the virtual machine. Now this is these are the 4 fields. Slot field provides integer index identifying each region of memory. So if we have multiple regions, we can identify using them this index. And this is the physical address where this particular buffer will be mapped inside VM. So if we access this particular location, we will be accessing first byte in the buffer here, and this is the address of buffer in host memory. This is size of memory. So this is how we attach the memory, and then we create a virtual CPU. Again, there may be multiple CPUs. For every CPU, this sequential index will change. Here we have only one CPU, and then every CPU will have data structure associated with it that is called KVM underscore run, that is used to communicate between guest and host. So if we have four virtual CPUs inside VM, we have to communicate with all of them using this particular structure, and that is how we will know that whatever is going on inside the VM. And while running it, many times your hypervisor will get notification from VM that VM has stopped running. It happens when your code has exited, or there is something that is trapped. For example, some address is access that you have decided to trap, or there is some sort of input-output stuff that is going on that you have to handle. So these are the general reasons when the virtualization will stop and you will get a notification. So this is the basic idea. We have to again figure out the size of this uh, KVM run structure, and then we map it in host memory, and from mapped region we access that structure. And now here, once we have done all this, then we set up the CPU. Right now we have set up the RAM, we have copied the code and data, and then we set up the CPU where these four lines remain as it is, because base and selector have to be 0 anyway. And then here we set it as per our code. So this is an instruction pointer. It will point to first byte of the code, and other registers as expected by your code. That is completely up to you. And then we set these register values to virtual CPU. And finally, what we do, we run an infinite loop, and then we ask the VM to run, and then when it exits, we check what is the exit region, and then we handle it accordingly. So most common region I already have covered, that there may be some input output going on, some memory access getting trapped, some error or something else. We have to check the exact value. This is the most common one that we are going to handle. This is when your code has executed HLT instruction. Here we are going to treat HLT as end of our code. So basically, whenever our code is going to terminate, it is going to run this HLT instruction. So when we get HLT, we say that okay, our code has finished. It is time to tear down the VM. Then for input output, if this is the case, then we check what is the direction. So if it is out, that means it is coming from VM to host, and if it is in, then it means that it is pulling something from host to VM. And then it will give us size, port number, count of data, and the actual data will be here. And depending upon which port number, how much size we are going to get, we can do whatever we want with this data. Maybe we just need to copy it, print it somewhere, draw something. That completely depends upon us. Same thing happens with opposite direction as well. Then these two are there for error cases. This first one will be returned when your VM doesn't even start, because that is in some unwanted configuration. And this one mostly happens when your VM has tried to execute some instruction that your virtual machine doesn't know how to execute. For example, if you try to run some 32-bit instruction into 16-bit mode, this is going to happen. So we handle these two just like this. Now, again, we can convert this inside shellcode. For example, if you have used shellcode, you can put some part of payload inside a VM, so that becomes more difficult for analysis. You can keep the payload encoded, encrypted, whatever, or you can keep it self-modifying. So even if there are certain limitations in host memory for self-modifying codes, because you have to deal with memory permissions, you can jump into a VM, you can do all that funky stuff there. And now it is demo time. So let me exit this. So okay, here it is. So the first thing that I want to show you it is uh, just see. Okay, so, can you see this code? Hello.
Yes.
Is the code visible? Okay. So let's see. This is the code that I am going to pass after decoding because I have kept it encoded. Here I am opening the device, and then at every step I am checking for errors that I omitted in slides. Then we are checking this API version. Then we are creating a VM. Then allocating memory. Then here we are decoding it. Here the original sequence is printed. Then here we decode it. That is simple XOR encryption. Then we copy the code in the buffer, and then here we are going to prepare this structure, and then we set this to we send this to virtual machine as its RAM. Then we create a CPU, and here we are going to set that kvm1 structure that is here. Then here we get the registers from VM. Then we are doing that base and selector to 0. Then we set it inside VM, and then again what we are doing, we are setting instruction pointer, that is first byte of our code. These are set because my code needs them, and the code is actually really simple. After decoding, that basically becomes that uh, add rax and rbx, save in some register, and pass it to some port to host. That is all that code is going to do. So we set the register, then we start running it. And here, since our code is going to write something on a port, we are eventually going to hit this. So we check that it is direction is out, as in from VM to host. Then size is 1 because there is only 1 byte that is going to come to us. Port number is this. This is the port that I am using in my code. And count is this because there is only 1 byte and there is only one IO stuff is going on. So then I read this, I convert it to character, and then I simply print it, right? And then I handle those error conditions, and finally I simply exit that. Okay, VM has terminated. So this is the basic code. Now, if I run this, this is what I get. Here VM starts. It uh, gives me this 9. That is the actual output because I passed it 5 and 4. And if I change this, for example, uh, say if I change this to 3, okay, and if I compile this again, test, test, and now I am getting 7. Whatever I pass in those two registers, they will get added. Now, okay, this is the decoded sequence, right? Now, suppose I want to debug this part of code. So, what I do that, let me see where exactly I have started the execution. So, I will jump straight to there. Okay, so line number 117. So, GDB 8 test. Okay, so right, and then what I do run, and here this breaks on this particular line where I am starting my VM. And now pay attention when I do next, what happens. This happened again, and then it switches there, and then it immediately comes to here, that there is some input output going on. The thing is that I do not get to even put a breakpoint on the code that is running inside VMC here. Right before starting the VM, I put a breakpoint and I am moving through code, and then my code runs suddenly inside the VM, and I have no clue inside debugger what to do with it. Obviously, I can uh, simply copy the code from here. For example, yeah, here I can try to dump it from the memory. But again, here I don't get to see this code running at all. And if my virtual machine is going to use some non-standard architecture, this is not really going to be of any use. Or even for same architecture, if I am going to utilize some other stuff like self-modifying code sort of thing inside the code that I am injecting in the VM, this again is not really going to be very useful unless our analyst can figure out some way either to convert this to uh, a more suitable mode, say protected mode or something, or try to figure out a way to run this on a 16-bit mode while still being able to debug it. This is not really going to work, and even if it is going to work eventually, this is going to be a lot of pain for the malware analysis, and that is precisely the goal that I want to achieve behind all this stuff. So this is the C code, and the assembly code runs something like this. So here I jumped to this label, and this is where my stuff is saved. That uh, this is a string, that is the driver path that I have to open. These are the parameters that I have to pass to registers, right? And then this is the memory size that I have to pass. So all these are simply hard coded here as data, and then here we have exactly same set of operations from our C code. So this is called open. I have commented out your error checking part. Then there are a bunch of IOCTLs that I have translated from C code, just like we were doing for VM create, setting up memory, setting up CPU, initializing CPU, and bunch of stuff. So I have just derived everything from those calls, and finally we are going to hit a loop. Yeah, this is your part where register data is getting loaded. This is where memory is going to get set, and this is your VM loop. This is where we check whether if there is some sort of input output going on. This is our exit case. This is where we are going to handle our input output from VM to guest, and this is where I have done that mmap and allocation part. So this is how we do it. Again, this code is really trivial. You can remove these commented out parts from this code if you want. I will share this code along with the slide with those spelling mistakes fixed with the null chapter leads. You should be able to get these files from them. Okay, so this is how it looks, and again, this is going to run very similar to that one. So if I run it directly, it says me 5 because I passed 3 and 2 to it. And for building it, it is not really uh, difficult. So I am back with the assembly files. What I do that I assemble it, and then I link it. And then you can run and check that, okay, yeah, this is actually working. So here I gave you example of very simple code just to add two values, but again you can put anything you want as long as you remain in 16-bit land, or unless you put unless you switch the mode to 32-bit. So you can once you switch to 32-bit, you can do a lot of stuff that you want. So yeah, this is it, and our topic completes here. So thank you everyone for your patience, and now I am open to questions if you have any.
We don't have any questions, sir. So if
Okay.
you guys have any questions, you can comment in the YouTube chat. Uh, so let us wait for 5 minutes. If there, okay, so it seems everyone understood too well. Yeah, so it's a lot to digest. Okay, so
Yeah, that I agree that this topic is a bit
yes,
difficult.
yes. Okay, so thank you, sir, for spending your knowledge and time with us. Thanks a lot.
Thank you for
So
giving me a slot,
thank you
man.
guys for. Sorry.
Thank you to you to you for giving me a slot.
Oh, okay. It's our pleasure. Okay, so let us conclude. Thank you guys for spending your Sunday. And okay, so here we conclude our meet. Thank you.